I'm Kayla.
I'm Nick.
This is Lab 9, Diffraction. This is OPTI 380A, Section B, RTA ZZ.
So here we have the 160 micron slit, and we're imaging through the camera an image just of the slit, but as we take the camera closer to the focus of the lens, we can see the diffraction pattern come up, and since it's the relatively large slit, we have the modulation pattern going out with the sync squared. This is the diffraction pattern for the 20 micron slit. The smaller slit size gives a wider pattern. This is the 40 micron slit diffraction pattern. As you can see, the dark zones are closer together. This is the pattern for the 80 micron. As you can see now, the dark zones are even closer together. This is the diffraction pattern for the 160 micron. As you can see now, it has the smallest spaces between dark zones.
It was calculated that the effective distance to reach the Fraunhofer region would be around 119 meters. Using the lens in the setup, this shortened the total setup length to approximately 37 centimeters.
Moving to a double slit, you can see the difference from the diffraction pattern in the single slit, and the profile shows a sync squared function with an amplitude of a cosine. With a larger double slit, we again see the smaller distance between the elements of the diffraction pattern. With the square aperture going through the Fresnel zone into the Fraunhofer regime, we can see the collapsing Fresnel zones, and then eventually we get to the Fraunhofer pattern there. Here's the triangle going from the Fresnel to the Fraunhofer regime.
This is triangle number 1.
This is a circular aperture going from the Fresnel to Fraunhofer region. This is the intensity profile versus the fit of the data, and this is our first and second maximum. So the first maximum is around 0.095, and the second maximum is around 0.065, but we have to offset that because it never gets quite to 0, so that's around 0.048. Okay, so for the circular aperture, we use the same process of finding the first and second maximums and then comparing it to the fit of the data. So we compared the sombrero squared theoretical fit to our data and got 11% error for the first maximum intensity, and for the second intensity maxima, we got a 33% error.